sorry, my software shut down on me at the end of that vocab there, but anyhow, what I was just to finish on this vertical angles, it's two lines that are crossing. See how there's two pairs of opposite rays, you know, if we were to add the dots for these lines that are intersecting. But the vertical angles are going to be pairs that are across from each other across the x, like right here and right here. That's one pair, and those will be congruent. When you have vertical angles are always congruent. And then this pair, so I'll give it 2 arcs, and this pair, and I'll give it 2 arcs as well. So the 1 and the 1 match, the 2 and the 2 match. Those are 2 congruent pairs of angles. Now in this picture you also have linear pairs. So over here, this one and this one create a linear pair, and this one creates a linear pair with this one over here on the right, also with this one on the side. So this particular crossing of lines creates vertical angles, linear pairs. It also creates adjacent angles. Lots of things can be done with those problems. One thing I don't think I mentioned a moment ago with the linear pairs is that when you have a linear pair, together they make a straight angle. And we learned the other day that a straight angle is 180 degrees. So together this linear pair will total 180 degrees. So they will be supplementary. But not all supplementary angles will look like this. Any two angles that add to 180 are supplementary. They do not have to be adjacent to each other. So in this diagram here, they're asking us to name complementary angles, supplementary angles, and adjacent angles. So complementary angles in this picture, they just have to add to 90. They do not have to be, you know, making a right angle together side by side. So here's the 52-degree angle and this 38-degree angle. If you were to add those two up, they would add to 90 degrees. So that's a complementary pair. So we're going to name these angles with 3 letters. B is the vertex, so it will need to be in the middle. So I'm going to say A, B, D. It's kind of like connect the dots. Angle A, B, D. That's going to be complementary with another one, so I'm going to have a little and symbol there. Angle BDC, or you could call it CDB, but D has to be in the middle because it's the vertex. So there's a complementary pair. A supplementary pair will have to add to 180. So 180 could be formed with the 52 and the 128. Those two angles would add to 180, so those are supplementary. So to name those, angle ABD and angle BDE, or you could say EDB, as long as the vertex is in the middle there. Okay, and then an adjacent pair of angles, to be adjacent just means they're side by side. So this angle right there, and then this one here, they share this side here. They share a common endpoint, D, and they're next to each other, and they're not overlapping. So those are adjacent. Angle CDB and angle BDE are an adjacent pair. Here they are wanting us to identify vertical angles, but it also says linear pairs here. And the problem with this picture is that there are no linear pairs. To be a linear pair, it must be just 2 angles creating it. And the only way I have for naming angles in this picture is these numbered angles. So I couldn't say 4, 5, and 6 because that's not a pair, even though they do make a straight line when you put them together. So for the linear pairs, I'm not going to have any because this picture doesn't have any. But the vertical angles, there's going to be 3 sets that are pairs of vertical angles. Angle 2 is vertical to angle 5. They're across the x from each other. Next, we could have 3 pairing with 6. We can also have 4, which is right here, matching with 1. Those are linear pairs. Or sorry, those are vertical angles, not linear pairs. I already said, no linear pairs on this one, just vertical angles. So 3 and 6, pair of vertical angles. 2 and 5, pair of vertical angles. 4 and 1, another pair of vertical angles. So right here, this is a linear pair. So the previous one did not have any. Here we have a pair of angles making a straight line. That means that together they will total 180 degrees. That's like hidden information. You'll see a lot of geometry. They try to hide information from you. This is a very typical way of them giving you information without telling it to you using this straight line. Suppose the angle measures formed by the pole of this basketball pole are 3x plus 8 and 4x minus 3. Find the measure of angle BCA and the measure of angle DCA. So we're going to find each angle, but first we need to solve for x to find it. So to solve for x, we need to put these together, combining our like terms, equal to 180 degrees. So 3x plus 8, the angle on the left, and then you're going to add the angle on the right. Together they make a straight angle, which is 180 degrees. 3x and 4x is 7x. Positive 8 minus 3 is positive 5. So those combine to equal 180. Subtracting the 5, 7x is 175. And dividing by 7, x is 25. But that's not the answer because they were looking for the angles, so be sure that you plug in for your angles. The measure of angle BCA, well, find BCA. Here's BC, and then up here is A. It's like connect the dots, so that's referring to this angle here. The 3x plus 8, so 3 times 25 plus 8 gives you 83 degrees. So BCA is 83 degrees, the measure of it. The M in the front means we're going to, say the measurement of it, versus if you just put the angle symbol, that's just you naming the angle, not talking about its measure. So that's why you see the M in the front. The measure of angle DCA, that's the other one, so that's going to be 4 times x minus 3. Or, since we know together they're going to make 180, you could also do 180 minus 83. You do end up with 97 degrees for that one. So there's our 2 answers for BCA and measure of angle DCA. The next one says that 2 angles form a linear pair. So I think it's best to draw a picture and think about how that would look. So a couple of angles making a linear pair. It says that the measure of one angle is 3 times the other. So I've got kind of a large one and a small one. It says that one of them is 3 times the other. So the one on the left is bigger, so I'm going to say that it's 3 times the other. I don't know what that other one is, so I'm going to call it x. So we've got x and we've got 3x. And together, they should total 180 degrees because they said they're a linear pair. So they're making a line together. So we need to add them together. 3x and x is 4x. 4x is 180. Dividing by 4, x is 45. But they asked for each angle. So that means that x would be 45 degrees, and then 3x, 3 times 45 degrees, would be 135 degrees. So our 2 angles, we're just going to list the measurements here. These are our 2 angle measures that we have. On these next 2, here we have 2 lines crossing, forming vertical angles and linear pairs. The way you're going to work the problem depends on where your variables are. Find your matching variables and then you'll know, am I using vertical angles or linear pairs? Here has a y in it and this has a y in it. Those are vertical angles. This one has an x in it, and so does this one. Those are also vertical angles. So I'm going to work this problem using vertical angles. And vertical angles are congruent. So this is going to be congruent to this. So the yellow ones are congruent. I'm going to start with those. So y plus 75 is equal to 3y plus 5. And then we're going to solve that. Subtracting y from each side will give you 75 equals 2y plus 5. Subtracting the 5, 70 equals 2y. And dividing by 2, 35 equals y. So the y value for this problem is 35. To get the x value, we're going to set these pieces with the x's equal to each other. So 3x plus 7 equals 5x minus 35. And then we'll solve that. So I'm going to subtract 3x from both sides. Will give me 7 equals 2x minus 35. Add 35 to both sides to get the 2x alone. That'll give you 42 equals 2x. And then dividing by 2, 21 is x. So now we have our x and our y. So those used vertical angles. As we look at the problem on the right side here, our pieces that have x's in them, those are a linear pair. And then there's only one thing that has the y in it, and it's right there. There's no other y. Since there's no other y, I'm going to have to find my x first and then use one of these yellow highlighted angles to put together with the 3y and solve for it. So I'm going to start by finding the x value. So these are making a linear pair. So they're going to add to 180 because they make a straight line. So we're going to add them up. So 6x and 15x is 21x plus 75. So I'm just adding them together before I wrote it down. Equals 180 degrees. So then subtract the 75 and 21x will equal 105. And then when we divide by 21, we'll get that x is 5. So we've got our x value. And then what I'm going to do is I'm going to plug in that x value into one of the angles, whichever looks easier. I think the 6x looks easier, so 6 times 5 is 30. So this angle's 30. And these two angles together, the one that I want to find because I want to find y, so I want to use this angle. These two angles make another linear pair. So that's another 180 degrees that we can find. So if this is 180 together and this is 30, 180 minus 30 leaves 50 degrees for this angle right here with a 3y. So that means that 3y equals, not 50, 150. 180 minus 30, 150. So 3y equals 150. And then when we divide by 3, we get 50 for y. So y is 50. So there's our x and y on our, using our linear pairs there.